Everyone, welcome back to the online classes. Dear students, the next problem is the question number 17. An athlete takes 2 seconds to reach the maximum height speed of 18 km per hour from the rest. What is the magnitude of his average acceleration? An athlete takes 2 seconds. Here the given values are time t is equal to 2 seconds. An athlete takes 2 seconds to reach the maximum height. To reach the maximum height, a speed of 18 km per hour. It is the maximum speed. P maximum is equal to 18 km per hour. From the rest means the initial velocity u equal to 0. What is the magnitude of his average acceleration? A average or your average acceleration. Average acceleration, right? An athlete takes 2 seconds to reach the maximum speed of 18 km per hour. Suppose if I consider initially the athlete is at rest, initial velocity of this athlete is rest. An athlete takes 2 seconds, time t equal to 2 seconds to reach the maximum speed, P maximum, to reach the maximum speed of 18 km per hour from the rest. Rest, initial rest ಅಲ್ಲಿ ಇರ್ತಾನವ. Rest ಇಂದ 18 km per hour speed ಗೆ ಮೂವ್ ಆಗಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ what is the magnitude of his average acceleration? Now the given value is maximum speed is 18 km per hour. Convert it into meter per second. 18 into 5 by 18. 18 into 5 by 18. We get the answer 5 meter per second. This is the maximum speed of the athlete. Initial time when he is at rest, time t1 is equal to 0. Athlete takes 2 seconds to reach the maximum height, that is t2 is equal to 2 seconds. t2 is equal to 2 seconds. And then the final velocity v is equal to 5 meter per second and initial velocity u equal to 0. These are the conditions. When a time t1 is equal to 0, the initial velocity is 0. An athlete takes 2 seconds to reach the maximum height and the final velocity of the athlete is 5 meter per second. From using these two values, you can calculate the magnitude of his average acceleration. We know the formula. The average acceleration is equal to v minus u divided by t2 minus t1. The final velocity is 5. 5 minus initial velocity is 0 divided by t2 minus t1. 2 minus 0. And then average acceleration is equal to pi divided by 2 is equal to 2.5. The SI unit of acceleration is meter per second square. The average acceleration is equal to 2.5 meter per second square. This is the desired value. Okay. The next question is the question number 18. Car moving with the velocity of 20 meter per second. Car moving with the velocity of 20 meter per second. The given data are initial velocity u. Initial velocity u. Initial velocity u is equal to 20 meter per second. Is brought to rest in 5 seconds. T is equal to 5 seconds. Time ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರಲ್ಲಿ 5 seconds. Brought to rest means the final velocity of that car is 0. By applying brakes, calculate the retardation of the car. When you are applying the certain force, here the car is come to rest. By applying the brakes, to calculate the retardation of the car. We know the formula. V is equal to u plus at. V is equal to u plus at. And then from using this equation, a equal to v minus u divided by t. Substitute the values in this equation. 0 minus 20 divided by 5. Then a equal to minus 20 divided by 5 is minus 4 meter per second square. A equal to minus 4 meter per second square. Here the negative acceleration, this is known as retardation. The negative acceleration, this is known as retardation. The retardation of the car is, 4 meter per second square. Here this negative symbol, this is known as retardation, or it is the retardation of the acceleration. Thus the retardation of this car is 4 meter per second square. This is the answer. And the next question is, a particle starts with a constant acceleration. A particle starts with a constant acceleration. A particle, it moves with a constant acceleration. At a time t second, speed is found to be 100 meter per second. Speed is found to be 100 meter per second. Time t is equal to t second. Speed is found to be 100 meter per second, means v is equal to 100 meter per second. And 1 second later, 1 second later means time t is equal to 1 second. And time t is equal to 1 second. 1 second later, speed becomes 150 meter per second. V dash is equal to 150 meter per second. Particle, initially it starts with a constant acceleration. At this time is t second, and then the velocity is 100 meter per second. 1 second later, speed becomes 150 meter per second. Find the acceleration of the particle. Find the acceleration of the particle. At this time, t is equal to t plus 1. Initially, time t is equal to t second. In this condition, the velocity of the particle is 100 meter per second. After 1 second later means t is equal to t plus 1. 1 second later, speed of the particle becomes 150 meter per second. The acceleration of the particle is, acceleration value of 100 particle. First equation of motion is, we know that first equation of motion. The first equation of motion is v is equal to u plus at. P is 100. 100 is equal to, initially it is at rest, u equal to 0 plus a into t. Therefore, 100 is equal to 80. This is equation number 1. Right? Velocity after 1 second. Velocity after 1 second. The velocity after 1 second is, that is, v dash is equal to 0 plus a into t plus 1. 0 plus, initially it is at rest, 0 plus a into t is equal to t plus 1. Velocity after 1 second. V dash is equal to 150. 150 is equal to a into t plus 1. This is equation number 2. Subtract equation 1 from 2. Subtract equation 1 from 2. When you subtract the equation 1 from 2, we get the answer here. The equation 2 is 150 is equal to a into t plus 1, minus equation number 1 is 100 equal to a into t. Subtract equation 1 from 2, we get the answer 150 minus 100, that is 50. 50 is equal to a into t plus 1, that is 80 plus a. Here 80 and 80 get cancelled. We get a is equal to 50, or the acceleration of the particle after 1 second, that is 50 meter per second square. A is equal to 50 meter per second square. This is the answer. Okay, thank you.